Now, we are going to take up one more program and how to find the roots of the quadratic equation. So when you try to find the roots of the quadratic equation, so what is the quadratic equation? We says the roots are minus b plus r minus root of b square minus 4ac by 2a. So obviously the header files which you can include is stdio.h and conio.h, and here we are including the math.h also. That is basically because we have the square root to be found out. So naturally the mathematical function is involved, so we are considering the math.h, which is the header file. So first we will going to define the name for the user defined function, which is quadratic. So what will going to be the nature of the roots? We will going to get the nature of the roots which we will going to get is having some decimal points. So we are going to declare that as a float variable, which is float a, b and c. So why? Because we have the formula for to find the roots of the quadratic equation is minus b plus r minus root of b square minus 4 into a into c by 2a. So we have a, b, c as the variables. Now first we are going to declare the roots, which is we get x1 and x2 are the roots, and of course every time we need not have to specify that is minus b plus r minus root of b square minus 4ac. So we are going to take that function disc that as discriminant root, that is square root of that number, that is this will be equal to b square minus 4ac is that the square root of that number. So every time we need not have to write that. So for that we are going to take that particular b square minus 4ac as one particular name as the variable, that is disc, which will going to be again, it will be in a decimal format, so float function. So we are going to declare that disc will be equal to, we are assigning that with b into b minus 4ac, that is 4 into a into c. So if that value becomes 0, so that means minus b plus r minus root of b square minus 4ac by 2a. So b square minus 4ac, that root becomes discriminant value, that becomes 0. Then what happens? You are going to get it as x1 is equal to x2, which is minus b by 2 into a, correct? No, because minus b plus r minus that entire root of b square minus 4ac, that particular value becomes 0. So it becomes minus b by 2a. Whether it is x1 or x2, you are going to get the same value. So that is the reason why we have written x1. We have written x1 is equal to x2, which is equal to minus b by 2 into a. Then printf, so we go for the printing of the roots, so that roots are equal because x1 is equal to x2. Then of course we want to control the number of decimal point after the point. So x1 is equal to percentage 0.2 f slash n, x2 is equal to percentage 0.2 f slash n, x1 and x2 are the roots. So then you return that particular value so that it comes out of this function. If the discriminant value is greater than 0, that means that is b into b minus 4ac having the value which is greater than 0, then x1 will be equal to minus b plus square root of the discriminant value by 2 into a. Similarly, then the two roots we are going to get minus b plus or minus, minus b plus and then minus b minus. So x2 will be equal to minus b minus s square root of discriminant value of b square minus 4ac by 2 into a. So now the roots are distinct, that is clear. So printf, x1 will be equal to percentage f slash n, x2 will be equal to percentage f slash n. So since we are not given any decimal point, number of digits after the decimal point, so it will going to print up to the 6th decimal point, which will be x1 comma x2. So then it's going to return those particular value to the main function. Similarly, x1 is equal to b by 2a and x2 is equal to square root of this. When we are having this complex root, fabs of discriminant value by 2 into ta. So the roots are complex. Here the first root is 0.3f plus I into percentage 0.3 f slash n into x1 and x2. The second root, that will be a plus r minus root of I, a plus r minus I into b. So here one it is plus and the other one it is the minus sign. So it comes to the return those particular values. So we are going to write the main function, main. Then of course float a comma b comma c. Then printf, enter the coefficients now. So read those coefficients. So what are the coefficients a, b and c? So the quadratic, we're going to call that function abc, then gets a function. So what will going to be the form of the output? When you are entering the coefficient of 1 minus 4 plus 4, so it will take the values of a is equal to 1, b is equal to minus 4 and c is equal to 4. So the roots are equal. So once you come to this, so here what happens is it comes to this particular value. So it will calculate the value of a is equal to 1 and b is equal to minus 4 and c is equal to 4. So it will calculate these values. So minus b, that is minus 4 into 4, minus 4 into 1 into c. So this one is equal to 0, it checks. So the roots are becomes real, which is the roots are equal. So that is how it will going to be executed. Similarly, it goes to the second function, the roots are equal. Then again enter the same procedure is followed for 1, minus 5 and 6. Then the value, substitute the values of a is equal to 1, b is equal to minus 5 and c is equal to 6, and it calculates the values. So the roots are distinct, that is x1 is equal to 3.00 and x2 is equal to 2.00. Then enter the coefficients of the third one, which is 6, 2, comma 4. So then a is equal to 6, b is equal to 2 and c is equal to 4. The roots are complex, that is x1 is equal to minus 0.167 plus I into my 0.799 and x2 will be equal to minus 0.167 minus I into I 0.799. So these are going to have the complex roots. So this is how you will be able to find out the roots of the quadratic equation. Now we are going to try to enter this program by using the code blocks. So first we need to write in, we are going to include some of the header files, then include conio.h, then include math.h because we having the square roots here. So once you do that, then we go for the quadratic, which is float a, then float b, and then float c. Then we are going to enter into this. So we are going to declare the variables, the roots x1 and then x2. Then I will going to consider that b square minus 4ac as one of the variable discriminant values. So disc will be equal to b star b minus 4 star a star c. So then if this expression is equal to 0, then x1 equals x2, which is equal to minus b by 2 star a. Then printf, the roots are equal /n. Then printf x1 equals %0.2 f/n. Then x2 equals %0.2 f/n. Then we will have x1 comma x2, that is the roots of those two roots values. So then you return to the main function. Then you go for if discriminant disk is equal to greater than 0. Now if disk is greater than 0, then we have x1 equals minus b plus SQRT of that disk discriminant values. So that will be divided by 2 star A. Then we have x2 equals minus B minus SQRT disk by 2 star A. Then printf the roots are distinct /n. Then printf x1 equals percentage 0.2 f/n. Then x2 equals percent 0.2 f/n. Then we have x1, x2. Then you return this value also. Then it comes with else what happens? You are going to take x1 equals minus b divided by 2 star A. Then x2, the complex root now, it will be equal to SQRT fabs disk then by 2a, that is the complex root, that is the negative roots. Then printf, so we have printf, the roots are complex /n. Then printf the first root equals percent 0.3 f/n 0.3 plus I percent 0.3 f/n. Then you will going to get x1 comma x2. Then printf the second root equals percent 0.3 f minus I percent 0.3 f/n. Then x1, then x2. Then again you return this value. Then we have the main function. Then you take this, so float a comma b comma c, printf. Then you have enter the coefficients. Okay, then enter the coefficients, then scanf, then you go to percentage f, then ampersand a comma ampersand b ampersand c. Then once you do this, then you call the main function quadratic a comma b comma c, then get ch function, and then it comes out. Now we will try to save this, then we will try to run the program. So what are the enter the coefficients? I will say 1 minus 4 and then 4. After calculation the roots are equal, so x1 is equal to 2.00 and x2 is equal to 2.00. Then we go for the second roots, then enter the coefficient. We are going to enter the values of a as 1, then b as minus 5 and the value of c as 6. The roots are distinct, so it will be x1 is equal to 3 and x2 is equal to 2. Then we have the complex roots. We have 6, a is 6, 2, b is 2 and c is 4. The roots are complex, so herein you will go to have the values of the first root minus 0.167 plus I 0.799, the second root will be equal to minus 0.167 minus I 0.799. So this is how you will be able to find out the roots of the quadratic equation in all the three cases. Thank you.